Hi everyone. So today we are going to talk about how to create an analytic data based on NHANES. So for the purpose of demonstration, I will work with a very specific and very simplistic research question. So for example, the research question is building a predictive model for diastolic blood pressure, and for that we will be using the dataset from NHANES 2013 and 14. If you think about this building predictive model, the model is much more simple in the sense that we do not have to worry about intervention or comparison because we do not have any primary intervention of interest. We do have some covariates and confounders and things like that. Covariates and predictors, not necessarily confounders, and the population is the US population because we are going to use the NHANES dataset, and also the time frame is going to be 2013-14 because we are dealing with a observational data source. So thinking about this research question, first thing we need to do is to do some literature research on what are the variables that are predictive of diastolic blood pressure. So looking at the literature that we're dealing with diastolic blood pressure, I can see that in their table 1 they are talking about a number of covariates, right? So age is a covariate, race is a covariate, and then they have this smoking, they have this drinking, the systolic blood pressure, the diastolic blood pressure are some of the covariates. So those are some of the covariates we are going to consider for our analysis, and for rest of the covariates such as this education or the poverty income ratio or some of the sodium and potassium intake variables, we are not going to use in this analysis for simplicity because I am leaving that as an exercise to you at the very end of this. So first let us work with this very simplistic problem where we have this outcome variable diastolic blood pressure and we have a bunch of predictor variables. Alright, so the second step is to find out whether the variables we are trying to use in our analysis, including the outcome variable and the predictor variable, whether they are available in a dataset that we are trying to use, right? So to do that, there are a couple of different ways. So in R, what we are going to do is we are going to use a couple of different packages. So the most important package that we are going to use today is going to be the NHANES A package. If you have not installed that package yet, you should go to the packages and then press install and write down this NHANES A. There are a couple of other packages that does similar tasks, but NHANES A package is the one we are going to use. Alright, after installing that, there is another package called NEAT-R. This package is particularly useful for displaying nice tables, and this package SAS export is particularly useful if you are planning on exporting your dataset into R, right? So this is the RMD file, and this is the neated file from the same RMD. So if you remember, in the lecture 1 I have described the demographic component of the NHANES dataset. So there are multiple components in NHANES dataset. Demographics is one of them, dietary is one of them, examination is one of them, laboratory is one of them, questionnaire is another of them. So these are the main available tables that are available for this NHANES. If you want to see So these are the questionnaire data, but I'm basically interested about 2013-14. And if you go to the website, you will see there is this demographic data, dietary data, examination data, laboratory data, questionnaire data. There are some limited access data for which you need some special permission, which is usually not available for public access, and there are some additional manuals and methods description as a help file. So in this particular lab, we are going to use some of these components, because the variables we are talking about, some of those are demographic variables, right? Say for example, the sex, age, race, marital status, and things like that. Those should be in the demographic component, but you do not have to remember which component contains the particular data you are trying to search. If you, after loading your package, the NHANES package, if you call the function enhance tables and then specify the group number, group name. So say for example, you are interested about the demographic component, you have to also specify the year number for which year this demographic component you are looking for. Then you will see the file name is demo under H. So this H subscript or index is assigned for 2013. So just to see what I mean, so if you go to the demographic data, you will see demo underscore H for 2013-14 data. If you go to 2015-16 data and you go to the demographic component, you will see the index is I, demo underscore I. If you go to 17, 18 and again go to the demographic data, you will see a J component, demo underscore J. If you go to 1920, I don't think the dataset is available yet. So when it arrives, it should be K index in that dataset. So we are working on 2013-14 data today with demographic, and this has this H index. But you do not have to come to this website. In R, if you simply write this enhance and then specify the name of the table and the year, it will automatically tell you demo underscore H. So this H index is the index for this particular year. You can then use the cable command on the same command. You simply, if you write down cable, it will give you a nice table. Compared to this table usually looks nice, and this is particularly useful if you have a table that has a lot of information. Say for example, when I am looking at the examination data, say for example, demographic component has only one data set, right? But if you go to the examination data, you will see there are many data sets under the examination, right? So if you want to know under examination what are the data sets, see, the first data set is about blood pressure. So probably our systolic and diastolic blood pressure variables will be found in here, but you do not have to remember. We can simply use some search function to find out. Say for example, remember I mentioned about this particular variable keyword search website within CDC or NHANES website. You can simply write what was our original variable, diastolic blood pressure, right? You can simply write diastolic and then specify which cycle. See, this blood pressure BP X underscore H is the one where you have some information, There are many other variables that contains similar information, and you can take a look at that in the same data file bpx_h. So in here, see bpx_h, so bpx_h. So this bpx is the name of the blood pressure variable dataset, and this h is the index for 2013. So there are many datasets under this examination component, and then you can simply use the enhance table variable command to see what are the variables that are available within the demographic component under this particular 2013 data, which is indicated by this H index, right? And you only need the names, you do not need any description. You can get this information from R, but you do not have to, right? Because you can simply go to age 2013, and then it should give you the demographic variables information. Go to the data file and you will see name of all of the variables in the table of content, and you can simply click on any of them to get more information about that particular variable. Say for example, this ACQN variable is the respondent sequence number. This is basically the unique identifying number that you will need to connect all of the different datasets that contains information about particular patients or the subjects. Alright, so if you simply change this name only from true to false, that will give you not only the names but also all of the detailed information or the variable description of what this particular variable represents. So it is certainly possible that within R we can try to find which variable has the specific name and what would be the description of that variable, but you can always go back to the CDC website and go to the document file and get this information. I personally prefer to go back to this original CDC website to get all of this information directly from here instead of searching from within R. But you can do that because that is one of the options that is available to you. Similarly, within the examination component, if you want to see what are the variables within this bpx_h dataset for the blood pressure component in 2013, you can see it can give you all of the names and the variable description. But then again, you can go to the NHANES website and go to the original blood pressure component to see what are the variables they have. Say for example, if you are looking for systolic blood pressure and the diastolic blood pressure, you can simply click on them to get a sense of how many were missing, how many had non-missing values, and things like that. Alright, so now that we know how to find dataset, then the next step would be to download the dataset and try to subset the variables that are useful for you, right? So in this particular section, what we will try to do is we will try to download some specific variables that we have already defined in our research question. So our research question was what? This is our outcome and these are our predictors. So we now go to our section 3, and we will try to get some of those variables. Say for example, age was one variable, gender was another variable, race was another variable, marital status was another variable. And we will also try to, remember at the beginning, we will also try to extract some of the survey features, because we will need them later for our variance calculation. So not only we are collecting the demographic variables, we are also collecting some of the information related to the survey features, the weights, the cluster or PSU information, and the strata information. Other than that, we also need this respondent sequence number. That information we will need. So to get this particular data set from 2013, because we already know that H is the index for 2013, we can simply write NHANES and then demo_H. That will download the data to a variable or an object called demo. So this demo object has a lot of variables, but say for example, some of these variables are not really useful for us for this particular analysis. So what we will do is we will not keep all of the variables that are not useful for us. We will subset our data frame and keep only the variables that matches these names. So what are the names? The ID number, the demographic information that are available in the demographics component, and the survey features. When we subset the data, then we can try to see how many variables we have left and things like that. So one warning message you will get when you try to subset the data and then translate the data. By translating, what I mean is that these data sets usually have factor names like 1, 2, 3, 4 for, say for example, marital status, married, divorced, and things like that. They will just assign 1, 2, 3, 4 values there, but you do not have the names there. To get the names, you need to use the enhanced translate, and that will convert the enhanced data into married, divorce instead of 1 and 2 and things like that. So in the process of translating, you will see there is a warning: no translation table available for SCQN, because SCQN is basically the identification number. There is no translation available for that, and the translation is also not needed. So that is why you will see this error message, but you can safely ignore that error message. And you can take a look at first 6 rows of the data by checking the head of the demo data that you have saved, where you have saved this translated enhanced data, and that looks like this, where you can see you have this non-Hispanic black, non-Hispanic white instead of 1, 2, 3, 4 numbers. So from this you can see you have the sequence number, the gender number, age, race, marital status, 2 different kind of weights, and the PSU number and the strata number. One point I want to mention quickly is that there are 2 weights, and it is very important for you to identify which weight is relevant for you. Say for example, if you are using the interview dataset or the dataset that was collected by interview, you can simply use this first weight. But if you are using the dataset that was collected in the examination center, the MEC examination center, then we have to use the second weight. I think in the class I will also discuss about this in detail. Alright, so we have some variables, but we still have some other variables that we have not collected yet. Say for example, the diastolic blood pressure and the systolic blood pressure, those are not in the demographic component. For that, we will have to go to the blood pressure component, and that blood pressure component belongs within the examination component. So if you go to the documentation of blood pressure, there are a couple of different variables that are available. Say for example, systolic blood pressure first, systolic blood pressure second, and you have to actually go through the documentation to figure out what they really mean, how many missing values you have. But the most important part is the target. In here, the target was male and females from 8 years of age to 150 years. So obviously not many people with this particular age was available, but this is just a range that they are using. Similar to this, if you go to the demographic component, you will see, say for example, this is the gender variable, right? In this gender variable, what is the target? The target is male and female between 0 years of age to 150 years. So you see there is the difference in target depending on which variable you are collecting. Say for example, in here, all of the people between 0 and 150 years of age, male or female, their data set was collected in here. But in here, when you collect the systolic blood pressure, you will see some of the patient's data set was not included in this variable. In particular, the people whose age was less than 8 years of age were not included in this particular variable. So it is very important to take a look at what this target is saying you, because if you are trying to merge all of this data, you will see a lot of missing values for the people who are less than 8 years of age, say for example. Alright, so we have identified that we are trying to get this blood pressure, systolic and diastolic, in our analytic data, and to get that we first read the data set and save it as BPX object in our R, and to read it we simply use NHANES function with BPX is the component name and H is the year. Remember 2003 was represented by H index. And after downloading that variable, you can see there are a lot of variables that you do not really possibly need. Only keep the 2 variables that you need, and also do not forget the respondent sequence number or the study ID number. And then after you download the dataset, assign the names and then translate the names into a dataset where you do not have factor names. You have the factor names as 1, 2, 3, 4. You have the factor names as is, as was described. But fortunately for us, see this 2 diastolic and blood pressure and systolic blood pressures are not in factor form; those are in continuous form. So this portion was not that necessary for this particular dataset. Also, in terms of the research question, we talked about smoking and alcohol. For smoking, you do not have that information in the blood pressure dataset. You also do not have that information in your demographic dataset. So one of the things you can do if you are not sure where you can get that particular dataset is to go to the keyword search, and in that keyword search simply write smoke, or maybe smoking. Let's try smoke first, and you can see there are a couple of different dataset that includes the smoking information. Yeah, there is the smoking cigarette component, right? This seems more relevant. I'm going there, and it should be smq_h. And one of the points I want to make quickly is that whenever you are dealing with a variable, say for example in our literature search we know that we are supposed to collect information about smoking, but if you look at the dataset, there are a couple of different options for smoking. One option was number of days smoked cigarettes during past 30 days, average number of cigarettes per day during past 30 days. This is cigarette smoke in entire life, right? Compared to that, what I have chose is that do you now smoke cigarette? So if you think this variable is not really representing what you conceptualize as the variable that is containing your smoking information, maybe you can use one of these variables. Alright, so you have to choose which variable is actually representing your research question better, and then choose the appropriate variable accordingly, because when you go to the dataset you see there are many different questions that are asked, and try to figure out which particular variable is suitable for you. Also note that the target is from 12 years to 150 years here. Alright, so you again download and subset the data, translate the data, and you see your dataset is now included. You can do the same for alcohol. Say for example, you can go to the search and you can try to figure out which component has this alcohol variable. You can see there are many different questions that are asked. Sorry, not 2017, I am looking for 13-14. So within 13-14 there is a component about alcohol use, ALQ_H. So go back to the ALQ_H document and then see there are many different questions that are asked about alcohol drinking, and try to figure out which variable is suitable for you. For me, I have chosen this average number of alcohol drinks per day in the past 12 months. So I chose that variable as a variable that is relevant for giving me the information about alcohol, but obviously if you go there are other variables, and try to figure out whether any of the other variable is giving you better information compared to this one, and then you can choose that one as well. So this is number of drinks, and some of the values are missing in here. So this is one of the key problems with dealing with variables such as alcohol, because it has a lot of missing values. And even though the smoking variable, when you collected it, it didn't have that many information about smoking either, and alcohol has less missing value but still has some significant missing values. Remember that our total sample size is probably 11,000 or something like that. Alright, so now we have demographic component data, we have blood pressure component data, we have smoking component data, we have alcohol component data. So we have 4 different data set, but there is a identifying number SCQN in all of those data set, right? SCQN was collected from all of those data sets, and that's why we are able to combine all of these data sets together. And to do that, there are a couple of different ways, but let's go slow and try to do it one by one. So let's say we are simply trying to merge the demographic variable with the blood pressure variable, right? And we want to merge it by the respondent ID or the unique ID, and we say all equals true because we want to get all variables from both of these datasets. And this is the first 6 rows of that merged dataset, and you can see these are all variables that were coming from the demographic component, and these are the variables that were coming from the blood pressure component, and they are linked by SEQN variable. Similarly, I have saved the dataset as analytic data 0, and now with that analytic data 0 I'm merging the smoking data, and you can see the smoking information is merged now, and I'm naming it as analytic data 1. And with analytic data 1 I'm merging the alcohol data using the sequence variable, and I'm saving it as analytic data 2, and you see the alcohol variable is now included. There is a way to merge all of these at once by using the join all, where you can just mention which datasets you want to merge, and then you simply mention by which variable you want to merge, and you set the type equals full, and that will give you the variables from all of these datasets at once. So it has the demographic variables, it has the blood pressure variables, it has the smoking variable, and it has the alcohol variable all at once. So you do not have to go through one by one in the as was shown in the previous step. And once you are done merging the dataset, it is probably a good idea to save the dataset. And to save the dataset, you have to save the dataset where the extension of the dataset is going to be .rdata, right? And once you save the dataset, you will see that dataset is saved in the location where you have the working directory set. Say for example, for me the working directory, and I can check the working directory, where is my working directory, by checking the getwd, and when I go to that folder I should see this particular file, and when I open this particular file I should see this particular object. So to explain what happens here, so I'm just going to click on this analytic data, I say yes, and then in the environment, see, I have saved it as analytic data, and I will see that dataset saved in the environment. When I click on here, you'll see the sequence, the gender variable, age variable, race variable, and all of the other variables are also included in that analytic data. So as mentioned earlier, there is an exercise for you if you want to try. This is optional, of course. Remember, in this particular paper, when we were looking at this paper to find out what are the variables that are associated with blood pressure, we found out that they have mentioned these variables, and among these variables we did not really consider this education poverty income ratio, sodium income, and potassium intake variables, so we did not include them in our analytic data. But now that you know how to find and search a variable in a given dataset, you can try to search that using the variable keyword search, and in that variable keyword search you can write down some of the name of these variables, right? So this education, if you just go to that search and select which year, you'll see in the demographic component that education variable is already there. Similarly, you can try to search for the poverty income ratio or PIR. Let's quickly see this PIR. So you might be able to get something relevant, a ratio of family income to poverty guideline, or something even more relevant. So you can search that. Similarly, you can search for sodium potassium intake.